All right, hi everybody. Today we're going to start lesson 2 of unit 3. We're going to look at what's called the 6 views of a function. Our learning target has changed. It states I will be able to represent a function by using the 6 views of a function. If one view is given, then I will be able to create the remaining 5 views. Our learning standard has changed as well. We're now into 8th grade function standard number 2, where we can compare properties of 2 functions, each represented in a different way. So when we learn about our 6 views of a function, we can compare it between 2 functions, is what our goal is after our 5 days of practice. So moving into the next slide, we're going to just do a quick review. It's not bad to hear it again of relations and functions from our previous study of lesson 1. Quick review, what is a relation and a function? Remember, a relation is between any 2 sets. Those sets are input and output values, and it's the collection of the ordered pairs. So you're going to write that horizontally in set notation, and that looks like this, which is just a quick example. Then once we have the relation where we can separate the input and the output values, we have something that we now look at to see if it's a function. And remember, that function is where each input is related to exactly one output. So what does that mean again? When we're looking at a relation, let me get a pen here. When we're looking at a relation, we need to check the x values to make sure that each x value is unique and has a specific output. So -5, -3, 0, and 1, if I had to state that input in numerical order, I could see as I'm listing the input values, I'm not repeating any of those. Each of those x values are unique. Therefore, this relation does represent a function. So let's erase this right now and look to see what is next. So besides looking at the relation to see if it's a function, we looked at a mapping diagram. We made sure that the format was correct. The left oval was representing let me shut that down. The left oval is representing the input values and the right oval is representing those output values. And again, we can quickly check to make sure by stating and looking at each input arrow only has one destination out. So again, this is a different view of function instead of looking at the relation. So we know a couple views of functions, and now we're going to look more in depth at those. So one important thing to be aware, oops, I took that. Okay, one more thing to be aware of is for our function rules, our linear function rules, there's some key concepts that we need to remember. The x term needs to have the degree of power of 1, exponent of 1, or nothing at all. Those are implying the same. It's called a linear function, and it's in the form y equals mx plus b. So we looked at many different forms of those when we studied in the last section of our notes, and we took a quiz recently on this. Those equations can be y equals mx plus b. Standard form matches exactly with an m and a b. Those could be a little off where the m value is 0, so all I see is the y equals b. We also could have our linear equation in different order, and that order is still acceptable since the x value still has an exponent of 1. This one here is what happens when my b value is 0. And then my last one, remember, we can read equations from left to right and right to left. So we need to become comfortable with seeing the y value on the left as well as that y value on the right. So again, you're going to see many different forms of those. Hopefully you're getting a little bit better. And the last of our major study in lesson 1 was our vertical line test. We use vertical lines to verify if a graph is a function. If our vertical line intersects at one point, it's a function. If it intersects at more than one point, we list that graph as not a function. And you can see here, all of these actually pass the vertical line test. All 3 of these represent different families of functions. So that is a review. Please, please make sure you have a pencil and paper next to you. Your output for today's lesson will be to upload your notes that you're about to take on the 6 views of a function and attach it to your Google Classroom post. So if you don't have it, go and grab it right now. All right, so today we're going to talk about the 6 views of a function. The following class, you're actually going to use your notes, which you're going to attach here and practice. Practice just makes us all better in the long run, and that's where you can ask a bunch of questions. So 6 views of a function, we're going to go over what those 6 views are. The first view is that function rule that we looked at, which is an equation. We're going to study the linear family of functions. So these equations will be in the form y equals mx plus b. And this is a straightforward linear function rule. Besides the rule, we can have a function graph. And that's what we did by looking at the vertical line test. So one other view is the graph of that function and what it looks like. So that's 2 views right now, which you are familiar with. Let's look at a different view. We have a function relation. Now, again, you should be familiar with the relation. It's something we studied in lesson 1, which is the set of ordered pairs. So that's in set notation, which are your braces to beginning and to end. And it's a horizontal approach to stating the ordered pairs inside the function, as well as the input and output values of the rule. So there's a connection between all of these 6 views. Let's look at the fourth. The fourth is your domain and range, which you should be familiar with. We separated those sets of domain and range values from your relation. Remember, your domain are your x values, listed in numerical order, and your range are your y values, also listed in numerical order. We don't do any repeats when we list the range values. And if our domain values actually repeat, it tells us that we're not actually studying a function. So we wouldn't be able to have those 6 views if we didn't actually start with a function. Another view that we're going to look at is a table, and that looks like a table of values where we're going to have 4 columns in our table. Our first column will represent our input or domain values. Our second column will be our work column, which will represent the function rule on top, what's happening inside that function. And then we're putting in the input into each of those x values, and we're processing and simplifying that equation to figure out what is the output value for that specific input value. Once we know that -2 produces a -11, we can state that as an ordered pair. So we do have 4 columns in our function table, and we'll be working with those. So we have our function rule, which is 1, our function graph, which is 2, our relation, which is 3, our domain and range, which is 4, and our function table, which is 5. And then we have the verbal model. So that verbal model is a representation of words, verbal, so that's language, of what is happening inside the machine. So instead of stating what's happening in terms of an equation, which is mathematical symbols, the verbal model states what's happening inside the equation in words. So this equation in symbols is y equals 2x minus 7. But in the verbal model, it represents 7 less than 2 times the input value is the output value. So the verbal model is going to take us some practice. We're going to use those keywords that we used in elementary school that represented operations and symbols. And we're going to use the words input when we're speaking of the x value, and we're going to represent output when we're speaking of the y. So here are all the 6 views of a function. We are going to practice those today. Most of these you should be familiar with. The verbal model is the most recent that you've done in the past, but maybe not when it comes to functions. So let's work on our first example. So what we're going to do is, how do I actually create the 6 views of a function? So to create the 6 views of a function, we have to be given one. We have to give something to start with. So we're given a function rule in this case, and our job is to create the other 5 views. So right here, you'll see the first thing that you're given is the rule, y equals 2x minus 4. So inside your function machine, let's say, you are processing, remember my sad function machine that I drew in class. We're putting x values into our machine, and y values are falling out of our machine. But what's happening inside? That inside computation is listed right here. So what this means is it takes the input value in, it multiplies that by 2, that input value, and then subtracts 4. And once those two operations happen, it then spits out and gives you the y value. So we got to process this. So we're going to make the other 5 views by understanding what's happening inside my rule. So the first view that we're going to make, we're going to decide if this is a linear function. Yes, it is a linear function since this equation is in y equals mx plus b. I can see the m value and I can see the b value, and I can guarantee that that x value is to the exponent of 1. So that linear function is going to help us a lot about our views. So the first thing we're going to start with is our verbal model. And I kind of said basically what was happening when I talked about the rule. This x value is where we start. So the input is being multiplied by 2. And then once that multiplication happens and a product is formed, we subtract 4 from the product. That's one way to read that. That's starting at the input. I could also say that this rule is 4 less than. Now remember, when we read subtraction, it's not the same way as we read addition and multiplication. 4 less than twice my input. I could say that as well. So our verbal model is something that we write in words, and I use that one. You also could use the one that I just stated, that you could say this is twice the input, or the input times 2, both are acceptable, twice the input minus 4, and it's all in words. We're not using any symbols, so 4 needs to be in letters. Twice the input minus 4 is the output. This, again, is an acceptable verbal model. There's no one way fits all when it comes to a verbal model. You just need to make sure that the rule and the symbols and operations match what you're stating in the verbal model. Okay, you can't change that. I can't change this to addition, and I can't change this into division. I still need that x being multiplied by 2, which is that twice that number or 2 times that input, and I still need subtraction of 4 happening. There's the minus 4 or the 4 less than. So I'm not changing any of the operation. It's just the way I deliver the rule in words is a little bit different, which is perfectly fine. The next view that we're going to do is a table of values. So far I have created one myself from the rule. So I have 4 more. So let's do the table of values. And like I said before, that table of values will be a chart. Okay, so here's the chart, but I'm going to talk you through it so that you can see where those input values came. So to build a table of values, we're going to use 4 columns. So on your paper, I want you to draw a big rectangle and then break it into 4 columns. That second column needs to be the largest, and technically that last column needs to be a little bit bigger, so that your work column is your second and your ordered pairs is your fourth. Your first column will represent your input values, what you're putting into this function. That center is your work, so that's where your rule goes so that you can see the processing of that function machine. The third column are your y values, and that last column is stating your ordered pair next to each other. Given this x, out comes this y. We always start our table of values with a header row, and that's what this is called. It gives us understanding of what comes and what's represented in each of those columns. So I'm going to choose some numbers. I'm going to choose automatically, I'm going to start with 3 values. My first value, and this is what you're going to do, will be negative an amount. So I'm going to pick -1. You can pick -2, -3. You need to start with a negative value. Then I'm going to draw a line across because I'm going to process -1 through that full machine. I'm going to process 0 as my second input value. I'm going to process that through the whole machine as well. And my last one will be a positive value. I'm going to pick 1 here. So you always have to start in your table of values, always a negative value, and that's up to you which one you want to choose. Your second value will always be a 0, and your third value will always be a positive value. I just happen to stick with 1. And I'll change that for some of the other ones so you can see how that works. So to process -1 through my machine, I have to substitute the x value into my x location in the equation. So y will stay y because I don't know what the output is yet. but I have to follow this rule. 2 times the input minus 4. So now I have to process this. 2 times -1, we start with multiplication first, order of operations, is -2. But I still have my next step, which is subtraction of 4. And here's where 7th grade integer rules. Same sign, sum. So I add 4 and 2 and I get 6. But I have to keep the same sign. So the sum of -2 and -4 is -6. So what that means, as an ordered pair, when I place -1 into this machine, out comes a -6. And we close it up, and that's our first ordered pair. That's going to help us build our relation in a second, and that's why we're building this. So let's process 0 through. I write my equation, I substitute. When I substitute that input value, it goes in parentheses. So 2 times 0 is 0, and 0 minus 4 leaves me -4. So processing 0 input value gives -4 as the output value. Last one for our column, substitute our 1 in our x value. Remember, your substitution needs to come in parentheses. 2 times 1 is 2, and 2 minus 4 is my last. Different signs here. 2 is positive, 4 is negative. Different signs, so I find their difference. So the difference between 2 and 4 is 2. And I keep the larger number sign, so I keep the -2. So now I process this. 1 produces a -2. So there is my building of my relation. I'm using the table of values to help me build my next view of a function. So here we have our -1, -6, 0, -4, 1, -2. And again, I want to see those 4 columns, and all 4 columns will look exactly the same with that header row to start. One value is negative, our second value is always 0, and our third value is always 1. And you can see it a little bit cleaner right here, the same exact thing we just did and process. So once we fill out our table of values, where do we go? And we go to that domain and range. So the domain values would be your first column, would be your X, your input value. So I'm going to list those, -1, 0, 1, and 2. And you might say, wait a second, Mrs. Anderson, where'd the 2 come from? Well, I just gave me another one, and I'm going to follow a pattern to figure out one more in my range. You'll see how this works. Then in my range values, remember your range values is right there in the table. It's the third column of your table, which are your output values. And I'm going to make sure that those go in set notation in numerical order. So where to get the 0? So let's look. -1 produces a -6. All right. Then the -1 goes up to 0 and produces a -4. So that means I can see that something is happening here between a -6 and a -4. Then I have a 1 produces a -2. That means that this went up. And now you can see this is climbing by 1. This is climbing by 2. So I automatically know if I put the next one in here, that's 1 more, then my next output would be 2 more. This is all about patterning. In the beginning, if you want to start with 3, why don't you do a little stretch? Stretch knowledge there. See if you can figure out what that 4th one would be. Some of you are going to be pleasantly surprised on how much you understand patterns. So there's our domain and range straight from our table of values. What else is straight from our table of values? That's our relation. It's right there. It's that 4th column of your table. It's all 4 of your ordered pairs listed in set notation horizontally. So where do I go from here? Well, let's count. How many views do I have? I have 1, which was the rule, which is given. Verbal model is 2. Table of values is 3. My domain and range is 4. My relation is 5. I got 1 more. Does anybody know which one's missing? Hopefully you said it. It's the graph. The graph is missing. So we're going to take a graph, which I will have for you on your slides, and you're going to have to plot these points. And you're going to use either your table of values to plot those, or you could just plot using that relation. I'm going to go to -1, -6. I'm going to make a point. 0, -4. 1, -2. 2, and 0. And hopefully you can see this climb. You can see that the domain values is increasing by 1. The range values are also increasing. As X gets larger, Y gets larger, and that means a positive trend. X is getting increasing, Y is increasing. So now that it's linear, okay, there's a hidden word inside linear. Hopefully you all see it. It's not ear. It's the other one that's hidden in there. It's a line. I'm going to give you a little sneak peek, guys. Don't tell Mr. Cormier I told you this, but linear equations produces lines on graphs. We're not there yet, but I think that connection you'll be able to see. So I'm going to draw my straight line to the best of my ability. Hope you guys are as good as that. And I'm going to make sure I draw arrows because lines have arrows. And the last thing we do for a graph is we always label it with the rule. And we always label it on the right side. And I'm going to label that as y equals 2x minus 4. That's it, guys. There's all 6 views of your function, your rule, your verbal model, your table of values, your domain and range relation, and your graph. So those are the ones that you're going to be working on today. Let's try another one. And you're going to do more of this than me. So here is our, oh, I forgot. I actually showed you the points on here. Look at me. So there, I didn't even have to do it for you. Here are those points. And there's that line. Oh, there it is. All right, so let's try this one. Given a function rule, create the other 5 views. So here we go. Your rule is y equals 1/2 x plus 3. First question, is it linear? Yes, it is. It fits the mold, y equals mx plus b, and that x value has an exponent of 1. What about the verbal model? What would that look like? One way you could do this is half of the input plus 3 is the output. You could also say the input divided by 2 plus 3 is equal to the output. Please make sure you're using the words input and you're using the words output right at the end to make sure that you do have an X and a Y value. So I will be giving you feedback on those as you just completed that open response question. From our verbal model, we're going to go to our table of values. All right, so I want you to build your 3 columns. What goes in column 1? I hope you said the domain values. What goes in column 2? Yep, those is the work column where your rule goes in. What goes in column 3? Your range or your output values. And last, what is in your 4th column? Your ordered pairs. You are correct. So let's look to see what this is. So I want you to set up your 4-column table on your paper, and I want you to answer the following question, but wait until you're done building your table to do it. All right, how'd you do? So I chose -2, 0, and 2. Does anybody know why I chose that? Well, hopefully you can see that if I picked a -1, I'd be dealing with fractions. So if I'm taking half of a number, I want that number, that input value, to be an even number so that when I take half of it, I'm still dealing with an integer instead of a fraction. So remember I said that in a table, you can choose any negative number to start. Your second is 0, and your third is any positive value. So I chose -2, 0, and 2 to input into this rule. If you chose anything else besides -2 and 2, that's absolutely okay as well. Just make sure that the values in the end are all correct. So we have here -2 produces a 2, 0 is a 3, and 1 isn't a 2, 1 is a 4. So again, that's wrong on that one. So then we build our relation from there. So our domain values would be -2, 0, 2, and there's my stretch, 4. My range values are 2, 3, 4. And what's my stretch? So if I'm increasing this by 2 every single time, and this one's going up 1 every single time, I know that following my pattern, 4, 5 would be another ordered pair on this in this function. And let's build that relation. That relation should look like this. And what's our last one we're going to build? Which I'm not going to ask you to do that until you get into class. We'll have some graph paper, but here's our graph. And we have to graph that. Negative 2, 2, 0, 3, 2, 4, and 4, 5. And our last, connect that with our line. Isn't that cool? Linear equations produce lines on coordinate planes. So it kind of helps. If you get a really curvy thing going on here, you know you did something wrong in your table of values. You can go right back and self-correct. So let's see what comes next. It's another you try. Here's your rule. This one is y equals negative 1/3 x plus 1. What values should we use when we build our table for our x? So when I take a third of them, I end with integers. What's my linear or not linear? It's linear. And I'm going to give you a little clue. Do you see this negative out front? It has to do with a falling line. So little symbols that you pick up on will be explained later, but you might see some patterns in things that you do and discover. How about our verbal model? What would you say in this case? I said the output is 1 more than negative 1/3 of the input. I will give you feedback on what you said for your verbal model. Let's move on to the table of values. Build that table of values with your 4 columns. Be wise on the selection you choose for your input values. I hope you did what I did. -3, 0, and +3. I want values that are not even in this case because I'm not dealing with halves, but multiples of 3 so that I can divide them easily by 3. So I used a 2. Let me get my pen so that I used a 2, -3, put it in, it processed to a 2, 0, put it in, processed to a 1, 3, put it through, processed to a 0. So here is my ordered pairs. From that, I'm going to build my, ooh, look at me being tricky here. I went straight to relation instead. Is that okay to do? Absolutely, that's okay to do. Remember, you're building the 5 views. You can build them in any order you choose, as long as you have all 6 in the end, the given one and the remaining 5. So there's my relation. Ooh, I really did stretch factor here. I built one on both sides. Then from that, I built my domain. I pulled all those x values out. Then I built my range, all those y values out. And lastly, I went to the graph where I graphed all of those ordered pairs, -6, 3, -3, 2, 0, 1, 3, 0, and 6, -1. And if I graph correctly, what is this equation, this rule supposed to produce on a graph? A line. Hopefully you said that. So again, here is another, given a rule, produce the other 5. I hope you feel a little bit comfortable since you're very familiar with building all of these separately. The words always makes kids stumble a little bit. It's better to try than to leave blank. We'll talk about those in class. You can share some of your ideas out loud and see how you're doing on that one. So what you're going to do is take a photo of your notes. We had one whole page based on what are the 6 views, making sure that you have all 6 of those listed before you. We did a practice one of the 6 views, and then we did 2 you tries. I should see that within your notes. Please attach them to Google Classroom to this post by 9 o'clock tonight. We'll be reviewing the answers at the beginning of class tomorrow. So please make sure that you have that. And bonus, I want to see what you can do. So here's your exit ticket. So I want you to create the 5 views of a function. Do your best job on the graph. I'm okay with you trying to do your best. It doesn't need to be on graph paper, but try your best on graphing those points that you build from your relation or your table of values. Good luck, guys. I want to see those notes, and I want to see this unique problem given y equals 3x plus 1 as your final exit ticket uploaded to Google Classroom. Hope this helps. See you all tomorrow.